Okay, so I'm going to have to do this without the deck, unfortunately, but yeah, bear with me. And if I'm unclear on anything, just chime in and please do ask me questions. All right. So when most people think of search, and just bear in mind, this is me speaking now, and I'll turn off the screen sharing for now because we'll just focus on my voice because I can't share the deck. So when most people think about search, well, I mean, what do you think about? You think about Google, you think about text boxes, Stack Overflow, Amazon, Twitter, all that kind of stuff. Click the text box, typey, smack enter, results come up. Yeah, so far so good. That is search, but search can go well beyond that. Stuff like a chatbot, when you think about it, that's just search. You're asking a customer support chatbot a question, it's returning the result it thinks it's best. Instead of returning 10 or 100 results like Google, it just returns one result. Or think about what if you could search let's say you download everything off archive.org, which I don't recommend doing because that's rather naughty. But let's say you did that and you wanted to search for all your machine learning papers. So searching through PDF for some matching text snippets and getting those PDFs back, or even uploading a paper on, say, deep neural networks and getting similar papers back. Or something like Shazam, which I'm sure you're all familiar with. A Beyonce song is playing in the background, you hold it up and it tells you, oh, that's All the Single Ladies by Beyonce. So all of these are search. They're not using text. Well, some of them are the chatbot, yes. But the Shazam example, the PDF matching example, not so much. So that's what Jina does. It does similarity search. So it's all about, you give it a piece of data, it finds similar pieces of data. So that piece of data, it could be a snippet of text, it could be an image, it could be audio, video, even stuff like 3D meshes or amino acids. In short, if there's a deep learning model out there that can understand the piece of data you're giving it, then Jina can use that same deep neural net model to find similar pieces of data. And that's what we call neural search. Normally at this point in the presentation, I would explain things like vector embeddings and all of that stuff, but I think you all get the idea on that. So yeah, I'll skip the boring stuff you already know and come down to how to actually build something with Jina. So some background knowledge here is that Jina has three basic concepts. A document, and I said before we were talking about pieces of data. So text, image, audio, video, yada, yada, yada. All of those to Jina are documents. It's the primitive data type and it represents a piece of information, any piece of information. And then we have an executor. An executor is basically an algorithmic unit. It does one simple task, and we like to think it does it well, like Unix tools do one simple task and they do it well. So let's say you wanted to search through Shakespeare's entire corpus. That's a lot of data, you know. So first of all, we would want to do something like break it down. So we would use, let's say, a sententizer, a segmenter. So that would be one executor. It would simply break down Macbeth into all the different lines by all the different characters and give you something more manageable to search through. Or let's say you wanted to take those individual lines and turn them into vector embeddings, because otherwise, how the hell are you going to use deep learning in that? So that would be another executor, taking a piece of data and encoding it into an embedding. And then because we are building a search engine with Jina, you know, every search engine needs an index for fast lookup. So another executor might take this vector embedding and associated metadata and put it into the index that we will later search through. And, you know, an executor could do anything. It could simply take a piece of text and convert it to uppercase. Or take or look at the metadata, look at a URL in the metadata, and if the URL doesn't resolve, remove that piece of data from your data set. Basically, fundamental algorithmic unit. And then we take all of these executors and we chain them together into a flow. And a flow performs the big picture tasks. So executors perform very small, simple tasks, very granular, and a flow performs a bigger thing, like taking all this data, cutting it up, creating vector embeddings, indexing it, boom, that's one pipeline. And then another pipeline would be actually looking at that index, taking a user's query, converting that into a vector embedding, and finding the closest match in the index and returning that. So document, executor, flow. I wish I could show you the slide, but all the information is on learn.jina.ai or docs.jina.ai. In a way, oh, I really wish I could show this slide. I think of it a lot like Bash. In Bash, you have, or any Unix style shell, you have very simple programs that do one simple thing, basically like an executor. And you connect them together with pipes and redirects. And in a way, that's like a flow. You're taking a lot of these very simple little things and you're building them into something bigger. So in short, Jina lets you build a neural search engine, i.e. similarity search, with very few lines of code. The meme search hosted example I've got clocks in at under 100 lines, I believe, of Python. You can search any kind of data as long as a deep neural net can understand it. Jina also lets you scale up for deployment. So you could say, run the segmenting on one machine, and then you could run the encoding on another machine, because you'd want a big meaty machine for the coding, but snipping something up into sentences you could do on your laptop. It has just 3 simple concepts: document, executor, and flow. And with Jina Hub, which is really cool. So with Jina Hub, you can just use all of these things, all of these different executors with one line of code. Kind of like Docker Hub. You don't need to write all the stuff yourself. You just do docker run foobar baz. And with Jina Hub, you can integrate it directly into your code and not have to, say, work out how to integrate Hugging Face transformers or Spacey yourself. It's all there for you. And we'll be going over some of that in the notebook. Cool. So I guess now we'll jump into the notebook and I will share the link with you. Oh, we've got some questions. Love a question. A link to the Google Doc. The deck is not yet public because normally I'm presenting it, but I'll speak to my colleague Jo, who's been coordinating this, and she'll sort that out for everyone. She'll send the link along. Are the executors running in the cloud or locally or either? Any way you want. You can run them locally, in the cloud, on bare metal, in a Docker container. You can have replicas. You can do loads of stuff. I'm not going to go too much into that in the workshop because notebooks are very limited in what they can do, unfortunately. They're great for quick demos, but yeah, there is really cool stuff being done in production or almost in production with Jina now. And we also have Kubernetes support. All right. So, yep. Okay, notebook. Yeah, and I hope my video is still working. Share screen. Okay, we can all see this, right? I'll take that as a yes. So in this workshop, we're going to build a meme search engine using Jina. it'll search a data set of memes and it'll return, URLs to the images and a bunch of metadata. We're just going to focus on searching text because, we just want a quick tutorial. The version on examples.jina.ai also, when it works, searches images. And there's a link to the repo on examples.jina.ai as well as this notebook. So before we jump in, let's just have a bit of terminology on memes, so we're all on the same page. So we've got a meme here. This is poisonous. What? So the template, we call it surprised koala. And, the template, well, all memes are based on templates, otherwise you wouldn't recognize them as memes. There's the Drake approving and disapproving, or there's the normal Winnie the Pooh, posh Winnie the Pooh. Those are all templates. The caption, pretty self-explanatory. The URL is wherever the image is hosted. And we're creating a text field as well, which is just the template and caption combined. So when a user enters a search term, maybe it'll be koala school. And then it would find, possibly if it's in the data set, it would find surprised koala memes about school or about education, something like that. So doing the basics, we'll just do a bit of cleanup from last time. And I hope that this works well. Yeah, run anyway, because I just have one of those trustworthy faces. Oh, we're really having one of those days, aren't we? I am really sorry about all this internet stuff. The internet connection quality. I'm really hoping you can all hear me.
Yes, we were hearing you and we can see the screen. And also, maybe you can...
Okay, thank God.
Yeah, maybe our friend can show the slide if there is, like, if you just share the slide and the link, Magnimind Academy can share the slide with people and you can maybe direct them.
No problem. I'll do that afterwards because I have to remove a few sensitive slides.
Okay, good.
Cool. Okay, I'll get back to the notebook. Okay, so. Okay, great. It's actually doing stuff now. So I put a lot of functions into helper.py. They're not really related to Jina per se. They're just related to cleaning up the workspace and basic stuff. If you go to examples, well, you can see all of this stuff for yourself. It's all open code. So just done a bit of cleanup. We're going to enable some Jupyter extensions so we can see images in the notebook and disable some warnings because we like to live dangerously. Warnings are for other people. Normally, if we were building our own meme search engine, well, in my case, I indexed about 200,000 memes, but this time we'll just go for 50 because let's keep it short and sweet. We've got a few prerequisites. Because this is a notebook, especially a Google Colab notebook, it doesn't store state. So I need to wget the requirements, and then we'll install those and ignore warnings. As you all know, installing from requirements always takes time, but Jina is pretty lightweight. We have very few dependencies out of the box. Though if you want to use stuff like Torch, Transformers, TensorFlow, additional dependencies are optional. In our case, we won't be using any of those because we'll be using executors from Jina Hub well, we won't be using them directly. The executors we download will be, but we won't, it'll all be almost black box to us. Next up, we're going to process the data. We're using an open source data set from ImageFlip. I originally just nabbed it from Kaggle. And there were so many meme data sets on Kaggle, but most of them were just junk. So this one, it has really rich metadata, which is super useful because we're searching by text. And I don't want to OCR every meme. I mean, I could, but I'm lazy. So I wanted something that already had the captions. It also has recognizable memes because if you don't recognize a meme, it's just a dumb picture. And it doesn't seem to have anything too offensive. I mean, some memes are always a bit edgy, but there was nothing that I found that was absolutely appalling. If you do find something appalling, let me know. I don't need, and meme search engines are always going to be somewhat problematic because of the data you're working with. Anyway, it kind of sucks as well because memes get stale fast. So these memes aren't the dankest, freshest memes straight out of wherever young people get memes. Okay, let's download the data. We'll store it in a directory that we'll imaginatively call data. Again, most of these things just ignore warnings, the flags. Now, as you know, being in data science, every data set is different. And because we're just using this raw data set, we didn't do any pre-processing, or I didn't do any pre-processing beforehand. This is where we'll do it now. So, here we are, yada, yada, yada. This stuff's about how the file is organized. But yeah, here we're creating documents for each meme, creating some metadata, the tags, that's generated automatically. If you give it a Python dict, it'll just use that as metadata out of the box. And the image URL in the dataset is malformed. So this is just fixing it up. And then we're storing these docs in a document array, which is up here, which is basically a Python list, but with a few extra features to make it more useful for Jina documents. So we'll do the usual imports, define the function, because it's a JSON file, import JSON, of course. If I were using a very simple data set, Jina can import stuff from files, let's say a directory of image files. You can do that with one method on document array, or you can import every row from a CSV file with one method, or even a relatively simply structured JSON file. It's just this JSON file is not pretty. So first of all, let's not shuffle it just to see what we get if we don't do that. Okay, we'll import a show images function. And then we'll just show the top 5 images in the document array. Okay, and as you can see, it's all just hotline bling memes because that's how the JSON file is structured. So what we really want to do is shuffle it so we get a more interesting data set to work with. Okay, so now we've done that and we show the images. Yeah, so we've got a whole bunch of different things. I always use a random seed so I can replicate results. 1337, of course. So as I said before, documents are passed into a flow in Jina. The flow is the pipeline that performs a bigger task, like indexing a data set or searching through the index that we've created. So we'll import flow. And this is really where the magic happens. So here we have, we're instantiating a flow and we're adding things to it because an empty flow won't do jack. So here we're adding an encoder to encode the text from each meme. And as you can see, we're using Jina Hub, yada, yada, Spacey encoder version 0.2. As I said before, using Jina Hub, it's kind of like using, I said using Jina was like using Bash. I would say using Jina Hub is like using Bash plus, well, apt-get or your package manager of choice. So if you go to hub.jina.ai, curse my feeble internet connection. So yeah, you can see we have a whole bunch of these things. We have all the clip encoders, we have sentence sizers, rankers, all the stuff you need for searching. So you don't need to code any of this manually. You can just integrate it with one line of code, which is, of course, what I'm doing here. Often, if I'm doing this on a larger scale, I do plus Docker. But because we're running this in a notebook, notebooks are a bit fussy about such things, especially if I'm running it on a remote machine like this one. We can pass parameters like model name. For meme search, I found the medium size model works well. And Spacey, in my experience, is a lot faster than transformers or sentence transformers or any of the Hugging Face stuff. Like it indexed 200,000 memes in just under 4 minutes, whereas waiting well over 40 minutes for what, I can't remember which sentence transformer model, but yeah, anyway, I was getting comparable quality results, but the speed was so much better with Spacey. And then we're just going to use a simple indexer. And this just stores the vector embeddings and the associated metadata in a really simple database. So yeah, let's create that flow. And if you're doing something more complex, you can chain lots more things together in a flow. And we're just going to use the same flow for indexing and searching, but you can have different flows for different things. So let's index our data. We'll input the docs that we created earlier. We'll give it a request size of 64 because why not? So here we go. It's downloading and unpacking all the stuff from Jina Hub. And I actually tested this yesterday and it worked. This is always I wouldn't say it's slow, but it's the slowest part of the presentation. So I'll look at the Q&A. How do you fetch metadata? So the dataset has a whole bunch of metadata in it. That's why I chose that dataset. Both image and metadata used for further search. In this example, we are only searching the text of the metadata. So if we go back up to, this koala meme, we would be searching through the text, this is poisonous, what? Surprised koala. But on examples.jina.ai, we do have a combination meme search. So you can upload an image and find similar memes. Or you can type in text and find memes with similar text based on the template and the caption. So one search is image to image, one search is text to text. And both of them return. In the front end, you'll see images being returned both times. In the case of the text search, that's just loading the image from the metadata. It doesn't even process the image in the text search. It just returns the metadata and shows the image. The image search does process the image. Those are both, I would say, unimodal searches. So you're searching image to image, you're searching one kind of data. Text to text, you're also searching one kind of data. On examples.jina.ai now, we have our fashion e-commerce search, the very early version. But in that, you can type a description like blue shoes, and it will turn that into vector embeddings using clip text encoder. And it's also indexed all the images using clip image encoder. So it shares a common vector embedding space. So you can type in text there and get back matching images, just like you would with Google image search. And that's been a lot of fun to create. Right now, I'm building on that. So in a few days, it'll have more advanced filters. So you can filter by price or by rating or by, the season of the fashion item, things like that. Hopefully it's still up and hasn't fallen down. I'm good at building things, keeping them up on the other hand. The business model, we are still a startup. So we've only existed since February last year. We just got our Series A. So right now we're all about building up developer mindshare. The business side of things, that comes later. Rest assured, we're obviously thinking about it and we do have ideas, but that's something I can answer maybe in a few months. We'll see. Okay, I'm just going to tag those as done. Okay, and it looks like the image search is done. Good timing there. So now that we've got our index, which we can see here in the workspace, as you can see, we use simple indexer before. We're running one instance. We're not running stuff in parallel. And it's just body and header. And both of those are binary files. There's not really much to see. But as I said, it's vector embeddings and metadata. So now we want to search through that index. Everything in an index is stored as a document. As I said, Jina's basic data type. So if we want to find, let's say, memes about school, we can't just send it the text school. We want to wrap that into a document. Or if we want to do an image search, we would wrap the image into a document. So documents in, documents out. It stays simple. So we'll create a query document. In our case, we'll just use one, but you could easily send an array of documents. So it could find, it didn't have more to go on. But in our case, we don't need that. We'll take that same flow, but this time we'll use the search method instead of the index method that we have here. We'll input the query doc. We'll say, yes, we want to return the results, and we'll attach that to the response. This is generally a much quicker process because we've already built the vector embeddings for everything else. We're just building the vector embedding for the text school. All right, there's some more Q&A. Is Jina open source? Yes, completely open source. We are under an Apache 2 license. Yes, and thank you, HW, for posting the link to the notebook. Yeah, I am all about open source. If it weren't open source, I wouldn't have joined. Most of my career has been involved in open source in one way or another. And excuse any background noise. Okay, so it's returned some results. That is good. And it's put them into response. So the response actually contains a lot of stuff that we're not going to go into because a lot of it's not super interesting. But I guess we could print it if we wanted. Yeah, so it's just a whole bunch of stuff with an ID, it taking the matches, all of these things. So let's just look at the actual matches. And if I were building this today, I would use the built-in Jina client. It's a bit more elegant than, actually, no. If I were building a RESTful thing today, I would use the Jina client. Right now we're using gRPC because Jina supports gRPC, RESTful interface, and WebSockets. And because we're in a Colab notebook, RESTful stuff isn't that elegant in a notebook. I haven't tried WebSockets, but I doubt it's much better. So gRPC it is. Once again, we'll show those matches. Remember the input document was school. So everything that comes up should be school related. Might not be perfect because we only looked at 50 things. There's no guarantee that there'll be enough of those that talk about school, but let's see what we got. Okay, my uncle's diploma says he graduated from a school of fine farts. Wow, charming. But we've got the word school, we've got the word diploma. This is definitely about school. First woman president, shirts arrived Monday. Okay, that's a dud. With small data sets, that happens. What it's like listening to nerds argue about which college is better, that's definitely about school. And this is where similarity search comes in, because it doesn't even mention the word school in the data we search. I'm particularly proud of this one getting in because this is, I read this and I think about a school scenario, but it doesn't mention school specifically. It mentions something that makes you think of a school dining room without saying it. And I guess this is because kids, parents, there's a loose connection to school, being a kid. But again, searching through only 50 documents, that's as good as we're going to get at this point. As I said, a better version is at examples.jina.ai. So right now it is broken, but there's a link to the demo, the repo, the notebook, all of that good stuff. A lot of these I need to fix, I'll be honest. The fashion search was working yesterday though. Now this is in a notebook. If I were going to do this in the real world, I'd probably want to use a RESTful API because I'd want a web interface. So in the notebook, this is how I do it. I'm sending it a predefined document. But if I'm doing it RESTful, you want to open it up to anything. So you could just expose the port, say HTTP, boom, RESTful interface is open. I'd use Dockerized containers. So as I said before, you can just do Jina Hub plus Docker, and that's much quicker. Yeah, and with Jina Hub, like I said, we have so much stuff. You can push your own stuff there, so other people can use it in their Jina flows. That can be either public or private, so you can attach a secret key, so only your colleagues in your company can use that execute that you have built. Because, yeah, you might have your own proprietary model that you don't want to share publicly. But, yeah, if you want to see code of something more production ready, that I would run on, say, AWS rather than in a notebook. And, you know, normally when I'm coding, I'm writing in Vim on the command line. I'm not mucking about in a notebook. But this is the fashion search example. And yeah, all of the stuff is here for building a fashion search. And even the fashion search is under 100 lines of code, because again, I'm leveraging a lot of stuff from Jina Hub. I mean, sure, there are always some helper functions. Front end is separate. I've stored some configuration variables here and there. But all in all, it's pretty short. So yeah, I guess that's a wrap for now. I'm more than happy to hear any more questions. Oh, wow, there are a lot of them. So anonymous attendee. With Jina AI, is search always done with a neural network, or can other machine learning methods be used? I mean, you could use other machine learning methods. We focus mostly on, I believe the key selling point of Jina is it makes it easy to do similarity search, and deep learning models are often an ideal thing to use for that. Are there other uses for the flow and executors other than search? Yes, you can pipe them together and do whatever you want. So in my example, I was using flow.index, flow.search. Those are just semantic sugar. They're shortcuts to what would normally be flow.post on equals quote unquote search, which is addressing an endpoint you call search. So you can have as many endpoints as you want doing arbitrary things. You can have flows that do arbitrary things. It doesn't have to be about search. It's just, that's our main focus. But yeah, you're free to do other stuff with it. So was school in the metadata, or was it related to semantic segmentation of the text embedded in the images? In this example, we didn't even look at the images. So the images were just the metadata. In the image-to-image search on examples.jina.ai, we're not doing any OCR, and we're not doing any image segmentation, though of course we could. I'm not sure if it would recognize. That's a big question, actually. Like, would it recognize, white impact font, right? Yeah, spelling out school as related to school. I guess that would depend very much on the image model. And I think some of the more advanced ones, possibly. How are the music and image embeddings generated? In that case, hang on. I'll share my screen again. Okay, where are we? So all embeddings are generated by using an executor for that kind of thing, namely an encoder. So on Jina Hub, we have a whole bunch of encoders you can use. So let's see, for video, we would use, say, video torch encoder. So we'd wrap a video into a document, maybe do some pre-processing, like cutting it into different frames, or in this case, let's assume not. And then we just pass that straight into video torch encoder, which would look at the data, create a vector embedding, and attach that to the document.embedding attribute. And then that document would be passed on to the index, and the embedding and the metadata would be stored there. Could I share a result of meme search later on Hub? So Hub, right now, we're mostly using it just for sharing executors. So the stuff that's specialized for a simple single task. So if you were wanting to build your own meme search engine using different models on a different data set, hey, go for it. I would say the best way to share that would be on your own repo. Does your company do any checking for malware in the code? So it's possible to see which code was created by Jina AI in the Hub. Is it actually? That's a good question. So let's check, because I know this was generated by Jina people. Okay, there's no way to actually see if it was an official Jina one. Except I guess you could go to the author, Jina AI. So that's the only way we have right now. But yeah, I'm going to take a screenshot of this and pass it along. Cool. If you could share how is the similarity between two embeddings determined? And you can use cosine or Euclidean similarity. I believe that's done by I'm not sure. I think the indexer has something to do with that. Yeah. HW, I would suggest joining our Slack and asking our engineers that question. I used to know the answer like an hour ago, but it's been a long night. Are deep learning models good at retrieving results for longer queries? Yes, I would say so. I mean, it depends on the model that is being used. Like certainly in the case of transformers, some are specialized for short text to short text, some are specialized for short text to long text. Like think about if you're searching Wikipedia and you search African elephant, and you'd get articles about, well, the African elephant, but also African animal habitats, safaris, things like that. So that would be short text to long text. And then long text to long text, if we go to showcase.jina.ai, we've got some official examples created here, not created by me, but we've got a PDF search. And no, I think in a previous example of this, it was you can upload a PDF and it'll find similar PDFs. So it was long text to long text, but that is certainly possible. How many employees does Jina currently have? We're at about 40 people now. We've been growing really fast. When I joined, I was like, I don't know, there were the founders and me. So that was in February last year. And now, yeah, pushing 40. Okay, I think that's all the questions. Great questions, by the way. I really love seeing this level of interest, and you all clearly have a background and know what you're talking about. Yeah, cool. I think those are the questions I can see. And I guess there's some chatter as well. Oh, in case I'm using PowerPoint, I could have shared a live presentation link. Well, I mean, normally I'd use open source software, but, you know, yeah, Google Drive. Yeah, normally I wouldn't. Normally I'd be sharing my Vim window, I think. But yeah, that's just me. I'm old school. Clearly MIT. What's clearly MIT? Truba, I hope I'm saying your name right. Yeah, I don't know Truba. Oh, right, the meme. Okay. Well, I mean, I could get sucked into arguing about schools I've never been to, but yeah, I'd rather debate Vim versus Emacs, frankly. Cool. Yeah, great questions. Yeah, that is some. I didn't answer the question about whether we're checking for malware. That is something I will be pushing for. I don't currently know the answer to that. Cool. And you can ask that on our Slack at slack.jina.ai. I think it's a really good question and it deserves an answer, and I just wish I could give it. Cool. All right. Well, thanks, everyone. I'll stop sharing my screen, turn on my video again.
Lol,
Hopefully the
Alex,
lighting is okay because I moved rooms. Whoa.
Can you hear me?
This is not great lighting. Yes, I hear you.
So thank you for a great presentation. It's a great product. It's fantastic. So thanks for everyone participating. And we're going to share the slides as when Alex shared it. Hopefully you'll get it. And then you can directly ask your questions to Alex, which I believe slides will have a contact information. So
that's right. The best way to contact me is, actually, I'll put it in the chat. to everyone. Normally I'm on Twitter because I don't own a suit, but my LinkedIn is here as well. Twitter's honestly the best way. And my GitHub is here. So yeah, that's all my useful contact info.
That's great. Thank you. Yeah. Great. Thank you. Have a good day for everyone. Thanks.
Thanks, everyone. Have a wonderful day wherever you are. I will be having a beer and a very nice evening here.
Sure. Thanks.
Thanks, everyone. Bye-bye.
Bye.